Are you part of a Baja team that's looking for a solution to take apart CV axles? Here at Stony Brook Motorsports, we encounter this issue every year, and every axle takes up a considerable amount of time and effort just to take it apart. Thankfully, we have 4 innovative engineers right from this club that has made a device that will take it apart for you without having to destroy your own body and destroy hardware and devices themselves.
At Stony Brook Motorsports, we design, build, and compete with a performance single-seater off-road vehicle at Baja SAE competitions. Our design is completely custom from the frame to the powertrain and suspension. With this, we have a custom suspension geometry that requires properly sized axles that are hard to find. To remedy this issue, we get axles from our sponsor, 4x Pro, that match features to our components and modify the half shafts. Over the years, it has become harder and harder to take them apart, so we've stepped up to create a device to do it for us.
When you need a custom axle for your beloved vehicle, you need it yesterday. The team at Stony Brook Motorsports understands that. They have designed a fully integrated disassembly system for CV axles. The system is rugged, portable, and gets the job done. Disassembling CV axles is tough. If you don't want to bust your back, bust your tools, or bust your axle, you need the CV axle disassembly system. The system works by starting with electronic linear actuation. This is a modern-day solution that keeps you, the user, from having to do any of the work. First, we start with the linear actuator, which outputs a force of 1 ton. But that's not enough. We multiply it, then multiply it again to get 8 tons of force to pull on the axle. We do this by use of a lever arm. This lever arm has an 8-to-1 leverage ratio. This means that starting out with 6 inches of stroke at 1 ton, we end up with 3/4 inches of stroke at 8 tons. Believe me, it's enough to get the job done. The puller assembly, consisting of the yoke and the gripper bodies, is what puts all that immense force on the CV axle to disassemble it. To constrain all this, the force counter to the pulling action is put into the lever arm pivot bracket. This bracket, connected to the frame, helps control all the resultant forces that makes so the CV axle disassembly system doesn't move an inch.
For our custom manufacturing, we start off with our frame. Our frame consists of A513 1x1 by 120 thou square tubing. This is an excellent choice as this mimics 4130 material properties and is easy to weld. Next up, we have our lever arm, and this consists of 3 of these tubes welded together and 4130 link ends. This involves welding these 3 components together, where we employ pre- and post-heating processes. Our preheating involved getting the link ends to 600 Fahrenheit, and for the post-heating, we left our fully welded lever arm in a furnace at 1600 Fahrenheit for 2 hours and left it to cool down for over 36 hours. At the end of this long process, our lever arm is normalized to 870 Celsius or 95 KSI. Next up, we have our yoke, which is made out of 4140 heat treated. Our complex geometry was made with a wire EDM and then sanded to the appropriate shape. Next, we have our pivot bracket, which is 4130 and has multiple mounting holes so this device can account for different size axles. For the final part of the main assembly, we have our gripper, consisting of a 6061 T6 body and 4140 heat-treated attachment brackets to our yoke. Inside the gripper, we include neoprene and steel bushings, so we have proper friction and mechanical connection for the gripper to sit against on the axle. Last but not least, we have our cup mating plate. It is made out of 1144 and this bolts into the frame and provides as much surface area possible for the axle cup to sit against.
To apply our force on the axle, we use the PA17 linear actuator from Progressive Automations because of its max dynamic force of 1 ton. With our 8-to-1 lever arm, this satisfies our design requirement of 8 tons of pulling force. To control the actuator, we use the corresponding Arduino H-Bridge shield from Progressive Automations along with an Arduino Mega for for extension and retraction control, as well as for current and displacement sensing. The current reading was used to determine the force output of the actuator using a force versus current chart from the manufacturer. To power the Arduino and actuator, we used a 12-volt 20-amp power supply. For our user interface, we used an LCD screen to display current, force, and displacement readings, and the status of the machine. To operate the machine, a green button starts the operation, a red button stops the operation, and a rocker switch allows the user to manually extend and retract the actuator when the machine is not in operation. When the green button is pressed and the machine is in operation, it extends until either of the following conditions are met. The actuator is fully extended, the force reading reaches 2,000 pounds, or the force reading drops below 75 pounds, which indicates that the axle has separated. When any of these conditions are met, the status of the LCD screen is updated to tell the user what happened. For safety, our control system also offers an emergency stop button, and our electrical components are housed in a waterproof box. Also, to allow our users to stand further away from the machine while it is in operation, we have 8 feet of wire between the machine and the control box.
Here, the designers of the CV axle disassembly system will demonstrate the operation of the device. First, you will take the CV axle that is to be disassembled and insert through the top of the device. After that, position the first half of the gripper mechanism against the side of the axle. Once that is done, you take the second half of the gripper mechanism and bring it into place alongside the first half. When it is properly aligned, insert the 4 locking bolts in through the aluminum gripper housing. Once those are in and torqued down to full tightness, insert the last long bolt through the yoke assembly into the gripper. Once that is done and torqued down, stand back and prepare to operate the device.
Now, for what you have been waiting for this whole time. Let's watch this axle bind against himself, taking up 8 tons of force and finally popping out.
Oh, no, yeah! I double tap. I record. I think if you reach over, you can just grab
As you can see, our machine can easily disassemble your axles with minimal effort. Looking at our data for pulling force and displacement versus time, the C-clip in our axle broke at about 10,000 pounds and separated from the outer cup quickly afterwards.